Okay, this is when we have different denominators. So your process is still the same. However, you have to do some additional steps. What do you need? It's page 13. Okay, so if you look at something like this, we already talked about this yesterday, but you would need to get them as a common denominator. We kind of talked about that. If you factor 4, I'm going to show you, we know that the common denominator is 4 because we're smart and we've done this before. This is 2 times 1. So our lowest common multiple includes each factor the greatest number of times it occurs. So 1 occurs once and 2 occurs twice. So it's 4 because we're going to be getting into rational expressions and that gets a lot harder. So you have to understand how you get the common denominator. So this is already over 4. Now I rewrite this over by 4 and I ask myself, what does it need? It needs another 2. And then you go about the business of what we did for today's lesson. We subtract the numerators and then we factor and reduce. We can't factor and reduce this. So for example, on this one, 12 factored is 2 squared times 3. 6 is 2 times 3. So my LCM, I'm going to take 2, the greatest number of times it occurs, listen Annika, times 2 times 3. So it's 12. We all know that, but I'm showing you how. Because, like I said, we're going to be doing it with rational expressions. So this stays as 7 over 12. This one, to get it over 12, I multiply by 2 over 2. I now subtract the numerators, and now you would reduce. After you add and subtract the numerators. After you add and subtract, you factor and reduce. After. Here, obviously, it's just 3 times 7. So this is 7 over 7, which is 14. Multiply this by 3, minus 15, and you get negative 1 over 21. So now, let's apply the same process to rational expressions. To add and subtract rational expressions with different denominators, you need to find the least common denominator. To find it, this is what I've been talking about. Factor each denominator. So if we have 3x, we have 3 times x. 6 is 2 times 3. Write each prime factor the greatest number of times it appears in either expression. So, what does it, the 2 appears once, the 3 appears once, the x appears once. So my LCD is 6x. So here it is. Here's the 6x. What do you need? Now you go to step 2, just like what we did here. Rewrite each term over the LCD. So here I needed to multiply it by 2 over 2, just like I did up here. And you get 4 over 6x. Here, this 6 needed an x over x. Okay, so you get x. Now you add them. Can I cancel my x's?
No.
No, because this is a binomial. It's not times, and you can't factor it. So you rewrite it over there, you add and subtract the numerators, factor the numerator if possible, and reduce. Notice where this comes. After you add or subtract. After. And you'll see some of you are going to get confused here. Right now it probably is looking pretty darn easy. So let's look at this. Okay, first of all, what would be my LCM on this one? 21, and then what else? Y to the 4th. I'm going to start out very easy. Like I said, this is one of the hardest lessons of the year. Okay, so you have, whoopsie, here we go. So, what do you need to multiply the 7y to the 4th to get 21? 3. So I multiply it to the numerator. You're going to multiply this by 7 and you get 14. Now you add your numerators, you get 23 over 21y to the 4th. Can I reduce anything? No, there's my answer. Okay. Jordan, what would be the common denominator here? Pardon? 100? I don't agree.
25.
100x. Thank you. You have to include everything. Now, it's not 2,500. That's not the lowest common denominator. If you look at 25x, that's 5 squared times x. If you look at 100, that's 5 squared times 2 squared. So my LCM is 5 squared, 2 squared, x. You include each factor the greatest number of times it occurs in either expression. 5 squared is the most it appears, so it's 100x. So now we're doing step 2. We're rewriting them over the LCD. I need to multiply this by 4, and Jordan, what do I need to multiply this one by? X. Talk right. So you have 16 minus 49x. You'll put this over. Now I'm going to subtract my numerators. Then you try and factor. Can I factor that numerator? Is there a GCF between 16 and 49? No, you are done. Okay, Darren, what do you think the common denominator of 4 is?
12b squared.
Okay, 12b squared. And if you guys disagree, please raise your hand so that I'll explain it. Okay, 12. What do you think it should be?
12b.
Okay, but it has to be b squared because it's the greatest number of times it occurs in either expression. It occurs b squared here. Right? Does that make sense, Zach? If you factor 12b, you have 2 squared times 3b. If you have 3b squared, you have 3 times b squared. LCM or LCD, it'll be 2 squared, it'll be a 3, and it'll be b squared because that's the greatest number of times the b occurs. That's what this said, greatest number of times it appears in either expression up here, right here. Let me zoom out. Zoom out. Okay, so where am I? Darren, what am I going to multiply the first one by? B. What am I going to multiply the second one by?
4.
So you have 5b and you have 60. So I get 5b plus 60 all over 12b squared. Can I factor anything?
Yes.
What could I factor, Zach?
5.
You can take out a GCF. So this is the first one that we could do that. Can I reduce anything? I still can't reduce because 5 and 12, if this was a 6 or a 4 or a 2, I could. But you have factored it to make sure that it's all done. Okay, so now we're going to go to this. This is a binomial. This is a binomial. I can't factor that. So my common denominator has to include both binomials, Asia. Okay? So I am going to rewrite these over both of these binomials. And this is where we get mixed up when we go to the binomial world. Okay. So on here, what am I going to have to multiply the first term by? What is it missing? C minus 3. So I'm going to multiply this by C minus 3 and C minus 3 to get it over here. So I distribute through here. Right now, when up here in step 2, please add this. Multiply. And you'll see what I'm talking to rewrite each term over the LCD. So right here, you multiplied this to get this. You multiplied to get here. We're going to multiply this by distributing. Please do that on that step. It will help you. Okay? Here, what does the second term need? C plus 2. I am going to distribute through now. And you get 6C plus 12. Okay, now let's look at our third step. This is where we were for today's lesson. You're going to add or subtract the numerators. So now I'm going to add them. And I get 11C minus 3 all over C plus 2C minus 3. Can I reduce that, or can I factor my numerator? No, you're done.
You can't cross out something.
What could I cross off? This is 11C. This is a binomial. It has to be exactly the same to cancel it. Okay, you guys try number 6.
How come on number 5 you couldn't factor the numerators?
Right.
Why?
Try the next one. Erica, what would be my common denominator? Look at number 5. X minus 1? Right. They're binomials, so it has to include both of the binomials. We're going to get harder, you guys. This is still pretty basic. So what do I need to multiply the first one by? X minus 1. And this one, x plus 4. Hans, what's my next step? And what would I get?
5x minus 5.
Very good. Please distribute. 3x. Now we're right to where we were for today. We add our numerators. We'll get 8x plus 5 all over x minus 1, x plus 4. Are we good? Okay, what's the common denominator? Good. 7. Thank you. Lost my head. Okay. Sina, what would be your common denominator? Eric, what would it be?
It's 2m plus 1 times 1 minus 1.
You can't factor either of those, right? I mean, it's not, you're going to get different ones. Okay, so now what am I going to multiply this by, Eric?
1 minus 1.
Over m minus 1, and this is 2m plus 1 over 2m plus 1. And I cannot stress enough, you multiply these, just like we did up here. We multiplied to get here. You have to multiply them. Don't leave it as m times m minus 1. You're going to get messed up, because then you're going to start canceling. No, you cancel at the end. So multiply m squared minus m, and what would this be, Eric?
It's 6m and then plus 3.
Yes.
It's m squared minus 1.
No, m times 1 is m. Okay, so now what would you get as your numerator?
M squared minus m plus.
Okay, can I combine the minus m and plus 6m and get what?
Plus 5m plus.
Okay, and can I factor that? Are there factors of 3 that add up to 5? No, you are done. So you're done. You leave this as factored. Okay, now let's turn the page and go zippity-doo-dah. And we go in subtraction. Okay, here we go. Okay, on this one, what would be my common denominator here? John, what would be my common denominator? X? X squared. Okay, so this just needs to be multiplied by x. So you're going to say, I'm just starting off easy. And then we subtract it and we would get 6 over x squared. All good there. Now, this just added a new twist here. A new twist. To find our LCM, remember we factored, back in the day here, we were factoring the denominator to find the LCM. So far, all of these on the front side, they were already all factored, the rational expressions. On number 9, Taylor, can I factor this denominator?
From the top one, yeah.
What could you factor?
The 4 and the 16.
Canceling, you're saying? You cannot cancel this. This is a binomial. I'm asking you, how do you factor x squared minus 16?
Difference of squares. So,
And what would that be?
x plus 4 and x minus 4.
X plus 4, x minus 4. So now, if you look at these two denominators, what would be my common denominator?
It would be x, both of them would be the same as the one that we got factored.
Okay, so it's x plus 4, x minus 4. Very good. So what do you need for your second fraction? Or your first fraction?
The top part needs to be multiplied by x minus 4.
And so does the bottom, right? To get it there. So what do I do now?
That whole fraction would be 2x minus 8
Beautiful.
over x plus 4 times x minus 4.
And this would just stay here. Okay, so now we got them over the denominators. This is where we were for today. Now you're going to subtract, so be careful. What would you get?
X minus 4.
Good, because this becomes a positive. Remember, that would become 2x minus 8 minus x plus 4. So that's how she got her x minus 4. Can I reduce anything? And what would my answer be then?
1 over x plus 4.
There we have it. Yay. Yay for you. Okay, Jay Lee. Can I factor this denominator? And what would that be?
2 or 3.
3 where? How would you factor a squared plus 6a? A outside, and then what's inside?
6.
A times what is a squared?
Was 1. And then plus 6.
6. And what would this one be?
3a plus 5.
So, what do you think our common denominator would be, Matthew?
3a brackets a plus 6.
You have to have the 3, the a, and the a plus 6. How about that fancy stuff? So now this has the a and the a plus 6, so what does it need? What is it missing to go from here to here? Matthew?
Oh, it's missing an a plus.
It's missing an a, so I'm going to multiply this by a over a. And what is this one missing? No, this is missing a 3, sorry. And this is missing a a, sorry. Okay, so now when you multiply these together, what do you get, Matthew?
You get 30a.
And,
3a.
and if I go 30a minus 3a, what do you get?
27a.
27a over 3a plus 6. Can I remove anything?
Yes.
What can you remove?
Move an A.
An a, because it's not plus a.
You can move
3 into 27 goes. So now you get 9 over a plus 6. Can I reduce the 9 and the 6?
Yes.
No, this is a binomial. It has to be exactly the same. This was factors, 3 times a times this. This is 27 times a. Okay, so, very good. Yes, Jordan.
Couldn't you, instead of doing all that, couldn't you just simplify the 10A and the A in the beginning? And
No, this is a binomial.
Uh,
Okay. Okay, Honia, how do you factor this?
CF,
Right, and what would that be?
2x times, parentheses, x, minus 4.
And this would just stay the same. So what would be my common denominator here?
2x versus x minus 4.
Right, so nothing changes with the first expression term, right? This just stays because it's already over the common denominator. What does the second one need?
2x.
2x. So you get 4x. So now, when you add those together, what would you get? Hello?
What I choose from here?
Yes. Don Chen, right? Don Chen? Yes, that's it. Okay,
Is that your name? Choose again. Yeah, I like.
So, on here,
Yes.
Honia, what would you get?
7x over 2x, parentheses, x minus 4.
And then what would happen?
And then you can cancel the x's.
And you get?
7 over 2 times x.
Okay, last one for this page. Okay, this one's kind of a nightmare, but it has all the steps in it. What is your first step that you're going to have to do? Right, you're going to have to factor the denominator to find the LCD. Remember right here, that's your first step, is factor the denominator if you can. Okay, that's your first step. So if you do that, you would have x minus 3 and an x plus 1, and you'd have to do it also for this one, which is x minus 3, x minus 4. So whoopsie doodly yay. What would be my common denominator, Max?
X minus 3. And then X. No, X plus 1.
X plus 1, and what else?
X minus
X minus 4. You have 3 factors down here, 3 binomials. Get out of town. Okay, so by this being factored, what is the first term missing? X minus 4. So when I multiply 2 binomials here, you would distribute it, okay? You would get 5x squared minus 20x plus 9x minus 36. All those skills that you already know how to do. Here you would multiply by x plus 1. This is easy. Easy peasy. So you would distribute, and what was the sign? It was adding, so you would have 6x plus 6. Notice I multiplied. Now I'm going to add the exponents. Do not leave them as factors in the numerator. Remember, Noah, stop bothering people. Here you multiply and rewrite over the LCD. That multiply means multiplying these two together. Now we combine like terms. I'd have 5x squared. This would be minus 11x plus 6x is a minus 5x. Negative 36 plus 6 is a negative 30. All over your common denominator. Negative 20 plus 9 is negative 11x. Plus 6x is a negative 5x. Okay, now, am I done? Can I factor this? By what?
Modify factor. GCF.
GCF. Good for you, Armand. Take out a GCF first. And now what would I do to the remaining trinomial? The diamond, and you would get negative 3 and 2. And some of you, if you don't need to use the diamond on these simple ones, you can go right to the two factors. Please be my guest. And now can I remove anything? This is when you reduce. Notice you factor after you add and subtract the numerator, right? After. I'm not going to go and factor this, then it just gets me back to here. You add the numerators or subtract them, and then you get your final answer. And here it is. You have all the skills to be able to do this. Okay? So let's look at it. We factored the denominator to find our LCM. Then we rewrote it. We multiplied by this over this, what it needed. We multiplied these. And then you add your numerators together, put it over the denominator, and then you factor the numerator. Look at our steps. Factor the denominator to find the LCD. I explained how. Multiply, rewrite over the LCD. Add and subtract the numerators. Factor the numerator, and then reduce. Okay, so do you understand the steps? Okay, so try number 1. Why isn't the snowman very smart? And let's see if you get it.
Do you want to go?
No, I don't.
Just try it. Think of the steps. See if you can do this. Like I said, if you got this, great. Great.
Take away your headphones.
I did have the answers. Okay.
Hey, don't do that.
Armand.
Be nice.
Okay. Okay. Are you guys all done working on this?
No.
Hazim, what's your first step in this? If you don't know, look on your page. It's on number 1. It goes right in order. I'd have your note taker out when you're doing the homework. It looks easy when I'm doing it, but when you go and do it yourself, you've got to keep things in the order. Emma, what would be the first thing you do? Factor the denominator. And check it out, class. That's what it says. Factor the denominator. Okay, so if I factor this, what would that be? x plus 2, x minus 2. So what's my common denominator?
X plus 2, X minus.
He said, thank you. So you have x plus 2, x minus 2. So, Hazim, does the first fraction or first term change? So, huh?
Yeah, you just factor.
I did just factor it. Does this change? Do I need to multiply it by anything? No. Safa, do I need to multiply this by anything? Well, x plus 2. And what would I get then as the numerator of the second term? Very good. We multiply those, remember? Okay, now Syra, when you subtract it, what do you get?
Negative 3x plus 2 over x plus 2x minus 2.
And you could have 2 minus 3x also. So, is that down here?
Oh,
It's right here, it's O. So let's put O down here. Any questions on that? Okay. Da 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 da. Okay. Try number 6. Just to make sure. Number 6. Diana? Oscar, what would be your common denominator? D minus 7? Very good. You can't factor them anymore, can you? Like you could, like Emma did over here. So you include both of them. Very good. See the difference. One you could factor, but these we can't factor. So what do I need to multiply the first term by? 3D plus 1. Awesome. And when I multiply that, what would I get for my numerator? 9D plus 3. You guys are really good in the distributive property. What am I going to multiply the second one by, Adam?
Like D minus 7.
And you multiply it by D minus 7, so what would I get? Yes?
You get 2D
2D minus
minus 14.
14. Okay, so when I subtract those LA out, what would I get?
7D plus 11, or minus 11.
How many agree minus 11?
No.
Sasha, what should it be? Plus 17. You have to distribute. Don't fall off the truck on that.
Turn that truck.
Okay. And that would be your answer. So where's that answer here? H. So we put H here. And we put H here. Okay, because it goes with H. Okay, so we'll kind of go through and complete this. Any questions?
We don't get anything.
Okay, you have a quiz on Monday, which is on graphing. The 2 branches, your asymptotes on simplifying and multiplying and dividing. Okay, we do not do 12-4 in this chapter, Michael. No 12-4, and don't throw things. Okay? So be ready for a quiz.
Yes, that's the homework. Didn't write it. No, I didn't. I'll sit down. When I walk up and when I called out.